Okay, so these are going to be the notes for stats, section 1.1 and 1.2. And here we're really going to get into a lot of vocabulary and definitions that help us to have a common language and a common terminology when we talk about statistics and data. First thing we need to understand is what in the heck are we doing? When we talk about statistics, what does that mean? And so statistics is defined in our textbook as it is the science of conducting studies for the purpose of collecting, organizing, summarizing, analyzing, and drawing conclusions from data. So we collect data, okay, through a study, and then we want to organize it, summarize it, analyze it, and draw conclusions from that data. Okay, there's lots of reasons we would use statistics, but some of them, there's a few here listed in the text, like being able to read and understand statistical studies that have been performed in a field. Okay, so for instance, maybe you want to be a dentist, and you have a salesperson, or you're researching on different approaches to helping patients deal with teeth issues or gum decay, gum issues, and you might look at, oh, look, there's a study that says that this is 85% effective. Well, you might want to better understand, what do they mean by effective, and what do they mean by 85%? There's more to it than just a number, and we want to be able to better understand that. We're going to definitely want to be able to dig into what statistics means and how do we deal with it. Once we're into the world of statistics, there's a couple of different types of statistics that we're going to talk about, but the first thing we're going to need to know is, what do we mean by a variable? Variables are something that we collect information about to describe situations, and a variable is a characteristic or attribute that can assume different values. It has to be able to vary. This could be your eye color, could be your height, your age, your income, anything that changes from person to person or from item to item, we can use as a variable. And now data are the values of the value of the variable over different samples. So if I selected your height, your specific height would be a data value. Okay, whereas height in general is a variable, the specific heights of individuals would be data points. Okay. In data, there are two different ways to describe or measure data. Those come into the two characteristics of descriptive statistics and inferential statistics. Okay, so these are over here on the right, you can see these are the things that I'm talking about. On the left here, you can see the textbook where we're pulling these definitions. Descriptive statistics consist of the collection, organization, and summarization and presentation of data. Okay, now this is really, really important that we understand what exactly we're talking about. In descriptive statistics, the statistician, or the person doing statistics, tries to describe a situation. Consider the national census conducted by the U.S. government every 10 years. Results of the census give you the average age, income, and other characteristics of the U.S. population. To obtain the information, there must have some means of collecting the relevant data. Once data is collected, the Bureau must organize and summarize the data. Finally, the Bureau needs a means of presenting the data in some meaningful way, like a graph, a chart, or a table. That is called descriptive stats. Okay, now this is really important. We're collecting data, we're organizing the data, summarizing it, like averaging, and then we're presenting it. Okay? Whereas inferential statistics consists of generalizing from samples to populations. So if I take a little sample here in Kimberly High School and then I apply that to all high schools in the state, that's a generalization. If I perform estimations and hypothesis tests, which we'll learn about later, determine relationships among variables, like exactly how does my height relate to my age. It's fine to say that they're somewhat related, but to be specific about their relationship, that would be inferential statistics and making predictions. Here the statistician tries to make inferences from samples to populations, using things like probability or the chance of an event occurring. These are the kinds of things where we make predictions and projections. It's no longer just looking at the data saying, what does the data say? Inferential statistics goes a step further, and we try to make assumptions based on what we see. A population, you heard that term, population and sample. So a population would consist of all subjects. It could be every car made by GMC. It could be every student at Kimberly High School. It has to be everyone, though, when we talk about that population. Whereas a sample will be a subgroup from a population. So I might take Mr. Welch's 1A stats class out of all of the school classes and say that's the sample I'm going to look at. What I find out in that one sample may or may not be true for the whole population, but it gives me a sense of what's going on, at least a snapshot. And it's much easier to take a sample than it is to measure an entire population. All right, let's look at 1.2, where we talk about variables and the types of data. Okay. In general, and this down here is going to be really important to us, so we're going to grab a highlighter. Down here, this in general is really, really important to us to understand these classifications. All data can be split into one of two types. We have qualitative data, which is data that's measured by some characteristic or quality such as hair color, gender, your state that you live in would be a quality. It's not a numeric value. Whereas quantitative can be something that's measured in as a number, something that's numerically valued. Okay, we can assign values to it. So, for instance, your height, your weight, the amount of money that you make in a year, those are all quantitative values. But within the realm of quantitative, okay, there's these two specific classifications. A discrete variable is something that can be counted. So we often think about discrete variables as how many or how much. Okay, and so we talk about those things as individual items. You'd count how many people are in your family, how many days of the week do you work. Okay, and so you'd count those as individual objects or individual days. Whereas continuous variables are things that can be any number, any of the infinite numbers between two values. So, for instance, a probability, okay, which is a percent chance of something happening, predicted chance of something happening, can be anywhere between 0 and 1. It could be 0% chance and a 100% chance. Any number in between could be the probability of an event occurring. The temperature is continuous. It can be 42 degrees, it can be 42.1, 42.11, 42.111. We could have all of these infinite temperatures. We may not be able to measure all of them accurately, but all of them are values that we can work with. Okay, let's take a look now that we're in 1.2, slide over, and talk about some examples of ways that we measure. There's different levels of measurement. Okay, the level of measurement that we talk about tells us how organized the data can become. If we don't have a good way of ranking information against each other, it's hard to say that one is better than the other. And so we're going to talk about these different levels of measurement and how they allow us to rank or compare data values. The first level, the most simple level, is what's called nominal level of measurement. A nominal level of measurement classifies data into exclusive groups, so these cannot overlap. You can't be in two groups at once. Okay, non-overlapping categories in which no order or ranking may be imposed. Okay, so nominal level would be things that there's just no way to rank one above the other. And the examples they put up here, let's grab our highlighter. Examples would be maybe your political office. Now somebody's going to say, oh, there's a number one in that group, but really they're just different classifications that have no numeric value. Maybe your marital status. Are you single, married, divorced, widowed, separated? Those don't have rankings per se. They might have higher, you might appreciate one versus another, but they don't actually have values. The department that you work for, if you're a high school teacher, are you a math teacher, science teacher? Those are classifications that don't really have a ranking, although we all know math is the best. Science is a close second. All right. The next level after nominal, where we've got no real way to rank the differences between them, is what we call ordinal. Okay, the ordinal level of measurement classifies data into categories that can be ranked, but precise differences between the ranks don't really exist. So some examples of this might be from student evaluations. Guest speakers might be ranked as superior, average, or poor. Floats in the homecoming parade might be ranked as first place, second place, etc. But these things don't have a way to measure the difference. What is the difference between first and second place when it's a judgment call during a parade? There's no real distinction between them other than one was put ahead of the other. So they are ranked, but there's not a way to say it's a 13% difference. It's really just one's better than the other. So that's what we call ordinal measurement. Our next type of measurement, the third level, is what's called interval level of measurement. This is where we have data. We're going to be able to rank that data, and there is a clear difference in the unit of measurement. Okay, so we're no longer talking about first, second, third place. We're now talking about 2 minutes in, 3 minutes in, 5 minutes in. We could talk about things like that. These would be things like your IQ test. Okay, you could have an IQ of 109 for one person, an IQ of 110 for the next. And there's a clear 1-point meaning in the difference in those IQ scores. The same thing can be said for temperature, okay, like in temperatures Fahrenheit. There, 1 degree Fahrenheit exists between 72 and 73 degrees Fahrenheit. These are things that have a very precise measurement system, but this is really important. There is no meaningful zero. Okay? For instance, 0 degrees Fahrenheit does not mean no heat. The idea of 0 would have to mean the absence of whatever you're measuring. So there is no such thing as a 0 IQ on an IQ test. There is no such thing as a 0 degree Fahrenheit, meaning that there is none of the temperature or no heat. It just is a point on the scale that's passed along the way. This typically means that things like negative measurements don't really make sense. So if you have negative measurements, you probably are not looking at the next level. You're probably looking at interval, where there isn't a true meaning to 0. The last level of measurement is what's called ratio level. Ratio level looks just like interval. There's a clear, precise measurement that's going along the way, and there is a true value for 0. It's not just some arbitrary value. It means none. It means 0 of whatever we're talking about. So down here, this table is actually really helpful at clarifying some of this. If we look at the nominal level, which means there's no good, better, best, we can look things like your zip code, where you live. It's just a number. And we can organize people by that number. But it doesn't mean that one's better than the other. Gender, male, female, eye color, political affiliation, religious affiliation, major, when you go to college, what's your major, nationality. It's just a description. You may prefer one over another, but they aren't actually things that you can rank. The ordinal level, things like your grades, A, B, C, D, F. There is not a clear definition between the different letters. Okay, there might be grades along the way, and you might say, oh, a 90% is the cutoff. But the issue with that is the letter grade itself, A, B, C, D, F, they're ranking, but they don't have a clear distinction between them. Percentages do, but the actual letter grades don't. Judging, first place, second place, etc., rating somebody, ranking tennis players. What's the difference between the best player and the second best player? We don't have a metric or measurement system for that. Interval data style, we're talking about things that can be ranked and ordered, and there's clear distinction between each number on the scale, but there's no 0. So your SAT score, you can't get a 0. IQ, you can't get 0. Temperature, there's a little bit of debate, which we don't do physics in this class, and we're not doing Kelvin scale. And since we're not doing Kelvin scale, we don't have absolute 0, so we're not going to talk about. Temperature is going to be something that isn't absolute, so there isn't a 0 for that. But your height, there is such a thing as a height of 0. It does mean something. It means no height. Weight, time, how many seconds? 0 seconds. Salary, your age. Those are all examples of ratio level. And that's what we need to understand. Hopefully this helps you fill out those note sheets and get an idea of what the differences in them are. If you're unsure, go back to the book and do some reading there. Good luck, and we'll see you in class.